This is day 71. We're going to be continuing to solve quadratic equations by completing the square. So now we're going to actually apply these to get the imaginary or complex solutions, which is an Algebra 2 standard. Okay. So just a quick reflection or review of everything we've learned so far reviewed. We had linear lines. Linear is like this: y equals mx plus b. What does your m do, everyone? What does m do? It changes the slope, good. So the bigger it is, the increase in slope counterclockwise, good. What happens when it decreases? It goes clockwise. Okay, what does b do, everyone? It's the y-intercept. It moves the graph either up or down, right? Okay. Then there was the next one is absolute value graphs. Okay. Absolute value graphs, the vertex is A, B, or not A, B, I'm sorry, B, C. Okay, and here's your graph, y equals A times the absolute value of x minus B, all plus C. What does your A do on this one, everyone? What does A do to your graph? Makes it wider or narrow, and what were you saying, Juliana? Good. Or up or down. Narrow or wider or up or down. So the farther away it gets from 0, the more narrow it gets. The closer it gets, the wider it is, and then it opens up if it's positive. What does B do, everyone? Good. Left or right? Good job. Thomas, left or right? What about C? What does C do?
Up and down.
Up and down. Good. Okay. So now we're moving on to quadratics. We're going to go through this one. So quadratics, remember, look like a U. Same idea. We have a vertex, which is going to be BC. Okay, and we're going to review this over and over and over and over and over and over and over again because it's very repetitive. It's very like, not in a bad way. It's just everything is connected. We could look at math simply and use it to help us. Okay, so the standard form, or I'm sorry, the vertex form of a parabola is a times x minus b squared all plus c. Oh, let me put that there. So what do you think a does on a parabola or on a quadratic graph? What does a do? Same thing, right? It makes it narrow or wider. B makes it move left to right, and C makes it move up and down. Make sense? Okay, cool. One more thing from last week. How do you divide a fraction? Not the butterfly. No, no, no.
Flip it, then multiply it.
Flip the second fraction and multiply.
Good, thank you. We flip it and multiply across. I heard that from a lot of people. So I would say multiply by the reciprocal, right? So isn't 1/2 divided by 2 the same thing as 1/2 times 1/2?
Yeah.
Which is equal to 1/4. Okay, good. I just, look at that. Fractions. You kids are awesome. Okay? So we need to know that for today. All right? Steps are the same today, but look, can you kids put in step 2 into your notes? This is a new step 2. This is, go to Friday's notes. You don't have to rewrite all of this, but can you please add this new step 2 in there? Okay? Okay, so we're adding this new step. It says if a is not equal to 1, divide both sides by the equation of a. So, like for example, if a is 9, what happens when you divide 9 divided by 9? What do you get? 1. Okay? Does that make sense? Or let's say you have 1/2 divided by 1/2. What's 1/2 divided by 1/2? How do you divide a fraction, everyone?
Flip it and multiply.
Good. 1/2 times 2/1 is going to be 2/2, which is equal to 1. Right? Does that make sense? So we're kind of connecting some things.
That's crazy.
You look confused. Is it good? All right, so here we go, numbers 1 and 2. We're going to just do 4 problems today. I'm going to do 2 of them, and the other 2 you're going to do, okay? These are going to be more advanced, so please pay attention. You're going to write both of these down after you're done, okay? I'm going to give you plenty of time to write. So pencils down, okay? Solve by completing the square. I could use a graphing calculator here. I could try to factor it, but I'm not going to do that. I'm going to use complete the square because that's what I'm asked to do, okay? So the first thing I want to do is move all my constants over to the right. So I got to take 69 and add it, or I'm sorry, subtract it, do the opposite. So I'm subtracting 69 on both sides. So we get 9x squared plus 18x is equal to, 69 minus 69 is just 0. Negative 8 minus 69 is negative 77. Okay. Then I notice that a is not equal to 1. A is equal to 9, so I'm going to divide both sides by itself. So I'm going to divide the left side by 9 because I wanted 9 divided by 9 is going to be 1 eventually. And then since I divided the whole left side by 9, I'm going to divide the right side by 9. Okay? So eyes up here. Eyes up here. 9x squared divided by 9 is 1x squared. Right? 18x divided by 9 is positive 2x. Good. Excellent. I say that because some students miss the 2x. Then the left side, negative 77 divided by 9 is negative 77 over 9. Just leave it. We can't simplify that, right? Now we're going to complete the square on the left. This left-hand side, we know there's a 1 here, so we can just erase that. We're going to complete the square, remember, on Friday. We take half of b, which is 2 divided by 2. So 2 divided by 2 when we square it. 2 divided by 2 is 1. 1 squared is 1. We just completed the square. And we're also going to add 1 here. Eyes up here. Some people are out there. Eyes up here. I just added 1 here. But I need to add 1 on this right side. But I need to add it like a fraction. How do I add 1 over 1? Right? The common denominator here should be 9, so I'm really adding 9 over 9. Do y'all see that? Okay. Now I'm going to take this left side. This is a perfect square trinomial. I know I could factor it. I could recognize that's a perfect square trinomial, so it's going to be x plus 1 squared, which is equal to negative 77 plus 9 is going to be negative 68. All over 9. Take the square root of both sides now. Use a different color here. So I'm going to get x plus 1 is equal to the positive and negative square root of negative 68 and the square root of 9. Okay, I'm going to subtract 1. X is equal to negative 1 plus or minus. And then we got, I could simplify negative 68. What does 68 become? Well, 68 is like saying 4 times 17. Okay. So what's the square root of 4, everyone? 2. So I could take out an I and a 2 and leave 17 on the inside. On the denominator here, square root of 9 stays as 3. Okay. So we're almost done. This is an okay answer, but we want to have a common denominator between these two. How do I give negative 1 a denominator right here? Put a 1 under it, right? What's the common denominator between 1 and 3? 3. So what do I have to multiply this first denominator by? 3. So we're going to just change this as x equals negative 3 plus or minus 2i square root of 17 all over 3. And that's it. Okay? A lot of work, right? Yes, sir?
The i's from the negative inside the radical, right?
That's right. A lot of little technical things here, right? So a question, what kind of answers are these? Real or complex, like an imaginary?
Imaginary.
So it's complex, right? Because there's an imaginary number. Complex. I think I told you imaginary, because there's an imaginary number. Remember, complex numbers are imaginary numbers. Good. What do you predict the graph will look like if you solve this?
It won't touch anything.
It won't touch the what?
The x-axis.
The x-axis. Make sense? Okay, cool. So that's number 1. All right. Number 2 will be complicated in a different way, but very similar. Okay? Here we go. Number 2. And you'll see it's going to be easier than the number 1. Ready? Number 2. I notice my constants are here on the left, negative 12. I have to move them to the opposite side, so I'm going to add 12 to both sides. So I have 1/2 x squared minus, oh, this should be x, I'm sorry. I made a mistake here today. This should be minus x. Okay, bringing down the minus x here. And leave a little space is equal to 0 plus 12, which is 12. Okay? Is my a equal to... Is my a equal to 1? No, I have to divide both sides by a. What's a equal to?
Half.
Okay, so I have to divide both sides by 1/2. How do I divide by 1/2? I multiply by The reciprocal, which is 2. Nice. Now you're getting it. Good. So I'm going to take this left side, multiply it by 2, and this right side, multiply it by 2. Right? I'm dividing by the reciprocal. So what's 1/2 times 2?
2.
No. What's 1/2 times 2? 1. Good. 1x squared. What's negative x times 2?
2x.
Negative 2x. Good. What's 12 times 2? 24. Okay, cool. You see how the fractions disappeared all of a sudden?
Yeah, that one's easy.
Yep. So now we're going to take this b, we're going to take half of it, do a side problem, make a c. C is going to be equal to negative 2 divided by 2. And we're going to square it. Negative 2 divided by 2 is 1. Or negative 1. Negative 1 squared is positive 1. I'm going to put a plus 1 here and a plus 1 here underneath. So we got a perfect square trinomial. X minus 1 squared is equal to, hey, 25. 25 is a nice number, right? We know that. So we're going to take the square root of both sides now. Square root of both sides here and here. So we got x minus 1 is equal to square root positive negative 5. Add 1 to both sides. X is equal to 1 plus or minus 5. What's 1 plus 5, everyone?
6.
Good, 6. So x equals 6. And what's 1 minus 5?
Negative 4.
Negative 4. There's your 2 answers. That's it.
I
Make-
like that one a lot more than that.
Yeah, the first one, our number 1 was more technical on the back end. You see you have this fraction you have to deal with. Number 2 is more technical at the beginning, right? So I wanted to show you both because I wanted you to see the procedure. Each one's different, so, but you could do this. Yes, sir.
How do you get the x minus 1? The log squared.
Right here.
Yeah.
Good question. Again, reminder, we got x minus 1. You see how this is a perfect square trinomial? So x minus 2x plus 1. Instead of doing all that work of factoring it, I recognize this as a perfect square trinomial, so I just converted straight to this right there. Were you here on Friday?
Yeah, no, I was here.
Okay. I shared that at the beginning of the class. So you know how you factor by grouping, break it apart. There's a lot of steps there, so instead we're skipping all these steps just to get to here. Does that make sense? Okay, cool. All right, you kids could do this. I know you could do this. It's going to take practice. Today's all about math procedure. It's all about procedure. It's not about the concept or even about applying it. We're just going to do procedure today. Okay, we got this. All right, so here's some talk. Let's start with twos today. Twos we'll talk about number 1, teaching the rest of the group about number 1. And then threes we'll talk about number 2, teaching the rest of the group about number 2. Ready, set, and here we go. Number 3. 10b squared plus 20b plus 72 is equal to negative 8. Okay, turn to your neighbors. Tell them what you would do first. What am I doing, everyone? Okay, you're subtracting 72. I don't mind the talking, I just need the students to be focused on math. What's negative 8 minus 72, everyone? Negative 80. Can you finish my problem for me? I think you can.
Yeah, I got it.
There's that a is equal to 10, so what are you going to have to do?
Yeah.
So here's how you do number 3. Number 3. B is equal to negative 1 plus or minus I rad 7. Some of you got stuck here. You're like, oh, what do I add here? I'm a little concerned. Some people are not paying attention. This is a repetitive step at this point. You take half of B, which is 2. I'm doing a side problem. 2 divided by 2 is 1. 1 squared is positive 1. Adding 1 to both sides. Does that make sense? Then you could factor it, take a square root, and solve. Okay? Here we go, next one, number 4. This one's going to be hard, okay? Push yourself to the end. You could do this, okay? Go. So yours should look like this.
Oh my god, you're right.
What? Okay. So this one gets kind of complicated at the end, right? We're working it out, and then we want a common denominator. What's the denominator of negative 1? It is 1. We're going to multiply that by 2 rad 2, so we're going to get, by rad 2. No, 2 rad 2, sorry. So it's going to be negative 2 rad 2. You see how this moves over here? Plus or minus I rad 17, and then 2 rad 2 stays in the denominator. And then you see how there's a rad 2 here? You have to rationalize it in the denominator, multiply by itself, rad 2. Numerator and denominator, we have to distribute that. So rad 2 times negative 2 rad 2 is going to be negative 2 rad 4, plus or minus I rad. Rad 2 times rad 17 is I rad 34, and then 2 rad 4 is going to be the denominator, simplifying there you go.
Yep.
Okay?
I got it.
I know. I'm
That was
proud of
hard
you.
stuff, man.
That was hard. If you could do that, that's really good. If you can't, I know you can get to it. So this is where we're at. So
I've done my deed today.
that is the
Sleeping
last
good tonight.
example for today. That concludes the lesson.
I did my